What's up guys, this is Shivam Raj. Today I'm gonna talk about candidate key. I have seen many students, they're finding difficulty to calculate the candidate key. So today I'm gonna give you a simplest method by which you can easily calculate candidate key. Fine. So let us quickly jump to this example. Here I have mentioned R, which is a relation, and A, B, C, D, E, F are the attributes of this relation. Fine. So here is the functional dependency given. From A tends to BC, C tends to E, A tends to D, and E tends to F. Fine. So what we need to do is we need to first draw a FD tree. Fine. So how we can draw? You just put all the attributes as a node. Fine. So here I'm going to put A as a node, D as a node, B as a node, C as a node, E as a node, and F finally. We have written all the 3 through 6. Here also 6 attributes are there. And now what we're gonna do is we're gonna see from here we can derive BC. From A we can derive BC. Fine. So we're gonna draw a arrow from A to B and again from A to C. Fine. Now again if we see the second FD, it says C tends to E, means C can derive E. So from C to E. Here keep in mind, arrow will be given to those nodes as given in the FD. Like here given C tends to E, so arrow must be pointed towards E. So I have done here, arrow is pointed towards E. Fine, you got it. So again we see the next is A tends to D. So here I've mentioned A tends to D. Fine. And again E tends to F. So here E tends to F. Fine. So we have completed the FD tree part. So what I'm gonna do is I'm gonna just decide the 3 vertex set. Vertex set which is going outside, vertex set which is coming inside, and vertex set rest. So in this vertex set we are gonna see all those vertex from where the relation is going outside. It means the arrow is going outside. There will be no any incoming arrows, only outside arrows. Fine. So if we see in this graph we have only A, because A, all the 3 arrows are going outside and no any arrows are coming into this node. Fine. So we can write here outside A. Fine. If we see D, no, in D only incoming node is there, incoming arrow, B incoming arrow, C incoming arrow, E incoming arrow, F. So we leave. So we see in this set we find only nodes we have which have only incoming node. If any node have both incoming and outgoing, so we cannot select those node. Fine. So we can select only those node which have only incoming node. Like here we have this node F. This has only one arrow which is coming and no outside arrow. So we can write here F. In such a similar manner we can see D only incoming arrows, B only incoming arrows. So here I can also write D and B. But if we see the node C, it will have both outgoing and incoming arrow. So we can consider it as a rest. Whatever be the node that will left after the derivation of both the set, we can write here in the V rest. So C is left. We have completed A, B, C. Sorry, we have just I have mentioned here B. Fine. So A, B, C, D, F, and we have left with 1 point. If we see E, both incoming and outgoing, so we can also write here E. because in both the nodes they have both incoming and outgoing arrow. So we have finally described this. So for the candidate key, what we're gonna see is we're gonna just first see the outgoing set. We take one attribute and find its closure. Okay, so how can we do that? We find the A closure. So if we see the FDs, or we can see from this graph, A closure equal to itself A, and from A we can derive B and C. So from A, B and C. So in the next part I should write ABC. From ABC we can derive E, and from A to D, first we see A, C to E. Fine. So we can write here E. On the next line we see from the A we can derive D, and from E we can derive F. So D and F both are derived from this. Fine. So we have calculated the FDs, and we see all the elements, all the attributes are coming in this closure. So yes, this is the candidate key. So A is the candidate key. Now we see the rest part. Fine. So if we find the closure of C plus, what we will get? We will get only E, C, and then only CE, because C derives E and E derives F. So we get after this line CEF, and here we need to stop, because CEF we have done with C tends to E, we have done with E tends to F, and no more node left to do. So we discard C, so D cannot be a candidate key. In a similar fashion we can find E plus. It will be only E tends to F, so it will be E itself and F, and no any other relation is left, or we can say no any other FDR left to put into that. So put into that. So fine. So here only F. So all attributes are not coming in this closure also and in this closure also. So we discard both the closures. So we have only first we saw the outgoing nodes A, and we have selected A because all the attributes are coming in this, and after that we only see the vrest. Keep in mind, this vertex set you discarded. You cannot take any of the attribute of this set, because all the arrows are coming inside to this node. So this type of node cannot be a candidate key, or cannot be a part of candidate key. So we first see only this outside node. If we are able to find, then it's okay. If we are not able to find, then we see the combination of VO and vrest. We can combine VO first element with all the elements, and again with, if we have any other element, then from that element we combine all the other elements one by one. Like in this condition we can combine AC and AE, but we have already found that A is the smallest, so we can take A as a candidate key. Fine. So here what we have find A as the candidate key. So we are going to close our process here. So in this question, candidate key is equal to A. Fine. So from A we can derive all other attributes. So this is the quick view of this candidate key. I made this video because many of the students find difficulty to find the candidate key. So here is the very easiest solution. You can easily calculate, or I should rather say you can quickly calculate the candidate keys. So hope this video helps. Thank you guys. If you like this video, give a thumbs up to this video and share it, and also don't forget to subscribe my channel. Thanks guys. Thanks for watching.